All right, so we have a short lesson today on solving using the properties of logs, so that product, quotient, and power properties that we've been doing. I'm starting out with a quick warm-up of solving the way we had done before. So go ahead, take a moment, pause this, and make sure that you guys are still doing it correctly. All right, if you were just coming back to your video, then I wanted to just post my work here. So if you need to pause and freeze the screen so that you could look at it. But remember, we want to either isolate the exponential part or isolate the logarithm part, and then undo using the inverse operation, so either the log or the exponent. And I left them all in just exact answers. So I guess that doesn't look totally clear. This is e to the 2.4 power divided by 4. All right. So moving on, we are going to start solving equations where the log just isn't in one spot. So still our first step is we want to get the log by itself, the logarithm part. And so you can see here that we are going to need to combine this 5 and this x minus 9 using the product property. So this plus sign here that represents multiplication. So for first step, let me zoom this a little bit. First step is we could write log of 5 times x minus 9 equals 1. And then I'm going to want to distribute that 5. So I have log of 5x minus 45. That is all in parentheses equals 1. And now I have my log in one place. So now I can undo it. So we are understanding that this is log base 10. So I'm going to use the opposite function or the inverse function. So I'm going to take everything, or 10, or take it to the power of 10 to the, well, you know what I'm saying. It's been a day. All right, so remember, if I take log 10 to the log, these undo each other. And so that just leaves me with 5x minus 45 equals 10 to the first power. Well, 10 to the first power is just 10. I'm going to add 45 to both sides. So I get 5x equals 55. And then if I divide both sides by 5, I get x equals 11. Now it said at the top of this slide to check for extraneous solutions. So I don't know if you remember other cases we've checked for extraneous, that usually extraneous happens when I have x in two places. So I don't expect this to actually be an extraneous problem, but we're going to check. So how do I check for extraneous? I'm going to take the value of 11, put it in for x into the original equation. So we have log 5 plus log of 11 minus 9 equals 1. That becomes log 5 plus log 2 equals 1. This is still multiplication, so 5 times 2 is 10. We have log of 10 equals 1. Is that a true statement? So, is log base 10 of 10 equal to 1? Well, let's check it by putting it in exponential form. So this is base 10. So if I rewrote this in exponential form, 10 to the first power equals 10, and that's true, so we don't have any extraneous solutions. But the next one, I think the next one we might, or we have the potential for. So if you take a look at this one, what's different about this one? I want you guys to think to yourself. What is this problem versus this problem? This problem has x in two different places. So it has a potential of having an extraneous. So here's what we're going to do on this. we still want to get one log in one place so that we can isolate it. So I'm going to change places with the 2 and the negative log x. I'm going to add 2 to both sides. So that gives me log of x minus 15 equals negative log x plus 2. Now I want to get the log x on the other side, so I'm going to add it to both sides, like that. So I get log of x minus 15 plus log of x equals just 2. And again, we should note right here that this addition means multiplication. So I would have log of x times x minus 15 equals 2. And then if I distribute, I get log of x squared minus 15x equals 2. All right. I hope you all understood how I got there. If not, just make sure you're making yourself little notes, questions you want to ask me. All right, so to undo log base 10, I'm going to take 10 to the power of this side and that side. These undo each other, giving me x squared minus 15x equals, this is 10 squared. Well, what is 10 squared? So you should have gotten 100. Well, this looks like it's a quadratic, and how do we solve quadratics? We need to have everything on one side. So I get x squared minus 15x minus 100 equals a 0. And I can either factor or use quadratic formula. So let's see if we can think of two terms that multiply to be negative 100 and add to be negative 15. And I think we have x minus 20 times x plus 5 equals 0. If I set both of those equal to 0, I get two answers. X equals 20 and x equals negative 5. And we need to check and see if we have an extraneous. This one's actually going to go pretty easy, because if I plugged either one of these numbers back into my original, what happens when I plug in the negative 5? So let's just take a look at that. If I plug in negative 5, and if you have a calculator, try taking the log of a negative number. You should get an error. So right away, I know that x equals negative 5. Though it was one of my answers, this one is extraneous. So it cannot work because I cannot take log of 0 or log of a negative number. All right. That is it for this first lesson. There'll be a few problems that go along with this kind of concept, looking for extraneous, and then I have another short lesson for this week of learning, all under the theme of solving logs using properties of logs, and there'll be a few problems associated with that.